In the last section of this unit, we're looking at inverse functions. So to know if a function even has an inverse in the first place, we have to know that it's 1-to-1. For a function to have an inverse, it has to be 1-to-1. To have an inverse, a true inverse, a function has to be 1-to-1. We'll just call it f of x. And there are some rules to find out if a function's 1-to-1. So just like to find out if something was a function, to find out if something was a function, if you were given ordered pairs, you need to know that there's no different y's that match up with the same x, right? Because if there were two y's that match up with the same x, then you fail the vertical line test. So if we have a point like 2, -1 and the point 2, 1, we know it's not a function. The 1-to-1 test is the exact opposite. So if I have the point -2, 1, if 2 points have the same y value, then it is not 1-to-1, right? And also we have this test called the horizontal line test to check and see if it's 1-to-1. These are things to check and see if they're 1-to-1. If they're 1-to-1, then we can find an inverse. If they're not 1-to-1, then we can't find a true inverse, but there is some wiggle room. There's some ways that we can work around that, and we'll see that by the end of this lesson as well. So let's check and see if these functions are 1-to-1. They're all functions because they don't have any matching x values that go with the same y value, right? To find out if they're 1-to-1, does this y value match with any other y values? Yes, it does. And they have different x values, right? So this is not 1-to-1. On the next example, we don't have any y values that match, so this one is 1-to-1. If you have no y values matching, then it's 1-to-1. If you have y values that do match, that don't have the same x value, then it's not 1-to-1. So here's our red flag here. Those y values match, it's probably not 1-to-1. If the x values don't match there, it is not 1-to-1, right? If we had -2,4 and -2,4, we're fine because that's the same point. You typically don't have the same point listed twice, though. The other way to tell if a function is 1-to-1 is with the horizontal line test. So this one, we're used to saying vertical line test. Boop, 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 boop. Never touches 2 points, so that's a function, right? The horizontal line test does just the opposite. That touches 2 points. It is not 1-to-1. There's nowhere here that you can ever touch 2 points, so this is 1-to-1. Here, see this vertical line test happening, right? It's not a function. It's not a function in the first place, but it is 1-to-1. It's not a function, but it is 1-to-1. Remember that if something is 1-to-1, if a function is 1-to-1, then we can find its inverse. To find out whether, if we're given two functions, for example, we're given f of x and we're given g of x, and we want to know if they are inverses, the way you check that is by doing f composed with g and g composed with x. If you get just x for both of those, then they are inverses. Let's see an example of that. So we want to know if f and h are inverses. Oh, I'm sorry, I'm looking at two examples separately. We want to know in the first example, if f and g are inverses. So for f and g to be inverses, we need to find f of g, and we need to find g of f. So f of g is 100 plus 12 times g, right? I'm going to write that as g of x. So that's 100 plus 12 times, g of x is x minus 100 over 12. When we distribute, the 12 over 12 will divide to 1. And when we combine like terms, that's just equal to x. So far we're good. That's what we wanted. We want to just get an x in the end. G of f is f minus 100 over 12. F of x is 100 plus 12x. Notice I just subbed in the f of x there. On top, the 100 minus 100 goes away. We're left with 12x over 12, which is just x. If both of those work out to x, then these two are inverses. Take a second and try h. So we want to know if h of k is equal to x, and if k of h is also equal to x. H of k would be the cube root of k minus 1. So that would be negative 1 plus x cubed, right? I just subbed in k. When we combine that, negative 2 plus x cubed, and there's no way to simplify that any further. And since there's no way to simplify that any further, and I can't get that to just be x, we already know that they're not inverse functions. I have a hunch that if you subbed them in the other way around, that you would also not get just x. You would get something like x minus 2. I'm not 100% sure, but I don't think you would get just x. So these, it doesn't get x, right? It does not simplify to x. So these are not inverses. The blue example up here, these are inverses. You could say something like g and f are inverses. Down here you could say something like h and k are not inverses. All right, we know how to check and see if two things are inverses. Now we need to try and find an inverse. To find an inverse, you're going to follow these steps exactly. You're going to replace your f of x with a y, interchange your x and your y, solve for y again, and then replace y with f inverse of x. This symbol, f negative 1, f to the negative 1, is read as f inverse of x, right? This symbol right here, that's the symbol for f inverse of x. Write an equation for the inverse function of this. All right, so let's follow the steps. Step 1, replace f of x with y. Step 2, interchange the x and the y. Step 3, solve for y. So we need to get y by itself. We can add 1. We can divide by 3. We get y equals x plus 1 over 3. And finally, replace y with f inverse of x. So that's f inverse of x equals x plus 1 over 3. If we wanted to verify, we could do f, let's call this for a second, just imagine that it was g. We could do f of g and g of f and make sure that they both turn out to be x. This is our inverse. If you sub those in, they would both turn out to be just x. All right, take a second, pause the video, and see if you can solve this one. So we'll replace the f of x with a y. Replace the y's with x's and x with y's. Then we need to solve for y, so we can multiply both sides by y plus 3. We can distribute the x. We can gather all the y's to one side. And here's a handy trick. You can factor y out as a GCF. Once you factor y out as a GCF, you can divide both sides by 3 minus x. And so since we have y by itself, we know that that is our f inverse. Again, you can verify that by subbing, by doing something like f of f inverse. And it should give you x and f inverse of f. And that should also give you x. And they do, so they check out as inverses. I'm just doing this mentally. I haven't written all this down. But if you wanted to go back and verify, you could sub one into the other into the first. All right, here is another example. This one, we're sort of worried on all the rest. If we had graphed them, they would have been 1-to-1, right? They would have been something that did pass the horizontal line test. On this one, it does not naturally pass the horizontal line test. So we would say that it's not 1-to-1 and we can't find the inverse. But they do give us a little caveat here, right? They give us this information that x is greater than or equal to 0. So what we can do is take this graph and chop off everything less than or equal to 0. X is greater than or equal to 0. We're only going to keep the right side. So we had a graph that looked like this. If we're only keeping everything x is greater than or equal to 0, that's everything from here forward. We're basically chopping off the left side. And by doing so, we do have something that now passes the horizontal line test. You see that? So now that we have something that passes the horizontal line test, we can go and try and find the inverse. We're going to swap m of x with y, interchange our variables, try and solve for y, so subtract 4, take the square root on both sides, change out our y with the f inverse of x. And one thing that I haven't mentioned before is that the domain and range is flipped for these. So if we looked at this one up here on top, the original function, this is our m of x. The domain is everything from 0 to infinity, right? It starts here and it goes everywhere to the right. The range is everything from 4 up, from 4 to infinity. In our blue function, the domain, remember we just can't square root a negative, so the domain is everything from 4 to infinity. And notice how that reflects the range. And if we were to graph it, the range is going to be the exact same thing as the domain up here, from 0 to infinity. They always reflect each other, where the domain of a function is the range of its inverse. The range of a function is the domain of its inverse. Final example here. Given f of x equals square root x minus 1, find the equation of its inverse. So first we can look at this graph. If we did the transformation, that shifts it to the right by 1. It's a regular square root function, so it should look something like this. That means that the domain is everything from 1 to infinity, and the range is everything from 0 to infinity. So down here, we need to have those reflected in our final answer. Go ahead and try and solve for the inverse. Swap out f of x with y, flip your variables, square both sides, add the 1, you have y by itself, that's your f inverse. The problem is, if we were to graph this though, this blue function, x squared plus 1 is a quadratic shifted up 1, so it would look like that, right? That's not the inverse because it's not 1 to 1, and so we need to find a way to restrict that. Again, we want the domain and range to reflect each other. So we don't want the domain of our new function. We want the domain to be everything from 0 to infinity. We want the range to be everything from 1 to infinity. All I'm doing is taking this and matching them up. They should reflect each other. Domain of 1 should be the range of its inverse. The range of 1 should be the domain of its inverse. All right, now to make this match, all I need to do is chop my new functions so that these match. Really focusing on the domain will help, right? If we only keep everything from 0 to infinity on the domain, that's from here over, that means we're only keeping the right side. So my new function is only going to be that right side. And so what we can do to restrict that is say we're only keeping everything from x greater than or equal to 0, right? So it's this function with the caveat that x is greater than or equal to 0.